is yeah. So now we move last Wednesday we talked about anyone still remember?
Event and set.
Yes. And set. We know about set and then conditional probability and then independent.
Duplication.
No? Mutually exclusive. What is mutually exclusive?
It's
With two events, there is no intersection. So this is mutually exclusive.
Oh.
No intersection. This is no mutually So if we do a formulation for this is A, this is B, so A union B, this is
A and B.
this probability plus probability. This is a mutually conditional probability. Still remember? This is the contrast. So if we have a conditional probability, the contrast is independent. Independent, there are no depend on this one probability. A depends on probability. Now we will do another rule about probability. So this is a multiplication rule and three derivatives. This slide, most of slides in this module, the same video can use. So this is for you to remember about the previous. So their probability, statistic, population example. So we skip it now. Sample space, sample volume, and then outcome, event, and then variable. Probability. Probability, low probability. Now this is the new things that we learn about three diagram and multiplication rule in the independent event. So independent event is not depend the other event. The independent event contrasts with the conditional event. So in the independent event, two events are independent if the occurrence of the event E1 does not affect the probability of event E2, event 2. So the probability A conditional B is the same with probability A because the probability A is independent with probability B. Probability B probability T with the conditional with the probability R, so the same with probability T. Two events are independent if the probability of their intersection in the product of their individual probability. So for independent event, we can know about the intersection of A and B by multiply the probability A with the probability B. if there are more than 2 events, we can generate formula. So for the independent event, we can calculate to know about the intersection between the event. We can make a product. This one, the multiplication of the probability of the event. We can make a symbol with the product of the individual probability. So this is we call it product. This one we call it sum. This one we call it product. So in the principle of the multiplication, if the first operation can be performed in n1 ways, and each way of performing is followed by a second operation that can be performed in n2 ways, then the two operations can be performed in n1 cross n2 ways. So if we have operation 1 and operation 2, in operation 1 we have maybe 4 ways to doing operation 1 and 3 ways for operation 2. So we can perform all cross. So there are ways. This means like this one. The principle of the multiplication. If the first operation can be performed in n1 ways and the second operation in the n2 ways and so on until k operation can be performed in n3 ways, so the sequence of k operation can be performed in n1, n2, n3 and so on until n. This is the way we can perform the operation. So this is the example. This is a tree diagram. So we can know about how operation we can do. So this is one first toss. The tree diagram for 3 coin toss. First toss, second toss, and third toss. So we can make if there this is picture and then this is number. So if we have a toss and then the coin we can get a picture. So we say this is G. So this is maybe success, this is fail. Success, fail. And then the second task we have 2 different outcomes, success or fail. So this is success and fail. You understand what I mean? And the third toss, we also have 2 outcomes. So success and fail. So if the sample, okay, so this is have 2 ways. This is 2 ways and then 2 ways. So we have 2 x1. Toss 1. So we have
8 ways.
1 way. 1, 2, 3, 4, 5, 6, 7, 8. This is the width. So we have this one. 1, 2, 3, 4, 5, 6, 7, 8. So the sample space is G, 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 A, G, 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 A, G, A, G, G, A, A, and so on.
I have a question.
Yes,
What is the definition of
P probability.
probability?
So if we want to know about the probability, we get G, G, G. So probability from the picture. This is G, G, G. So we square 3, and then probability for the A, because this is G, 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 only have G, but 1, 2, 3, so we have square 3, cross with probability A square 0. This one?
Is it possible if we want to count the probability of size?
Yes, this one. This is. So this is the conceptual. So we will in the next class we will have some case study. This is about test probability. The test probability we have 6 outcomes. This is only have
2.
2 outcomes. So we learn from the small, from the more simple, and then the next is more. In other side we focus. We have 52.
52.
So we learn from the simple things until the complex one. So this is the probability. If we want to know probability, first clause is we have G, second clause we have G, and the first we have G. So probability we have G square 3. So if we want to know about AGA, so A is the probability G, because this is G only 1, 1, 2, this is square 2. So this is for the probability. This is for 2 outcomes, but if we have a different outcome, so in the first toss, in the first operation, we have 2 outcomes, X and Y. Where is one? This X and Y, and then the second A, B, the third is alpha, beta, gamma. So this is X alpha, so the probability is probability X multiplied with probability A multiplied with probability alpha. This is the way we can have an operation, and then this is 2 plus 3 plus 3, and we have the until now, this is okay. Are you with me? Okay. And then the next one, this is for a tree diagram with replacement. So the probability will be same in the first trial, second trial, and third trial. This is the same. So for the success, we will see first trial success rate, trial. So we can calculate the probability. So for success, probability success, square K cross probability G. So this is relatively simple for we calculate about the probability. So this is we have PS probability of success and S of N is probability of failure and G and then NS number of success element and G number of failure element and then N total number of failure element NS plus NG. This is with replacement, but if we meet about the trial without replacement, this is what we have different probability. So this is an S number of success element for the first trial and G number of failure element for the first trial. This is the so this is the probability for the first trial. The first trial NS, and then the second trial is NS min 1 because we take one observation. So we take 1 point in the first time we have 10 sample space. In the second trial, we only have 9. So the probability is we know this is so we calculate the number. Maybe it's more simple. So this is the first one. Maybe we have one. The second. This is what the general formula. We will learn next. This is a more complex than this one. So now we will move to the simple one first. So this is the case study. So there are 10 holes with 4 success. So we call it, if we meet 4 holes, this is a success, and 6 red holes, we define it as a failure from 3 times. We have from 3 times. Yes, this is the probability of success. So the probability of success for 5 by 4 plus 6 is 10. PG probability of failure is, this is we call it for failure 6 by 10. So NS 4 and G 9. And G 6 and N. So we can calculate the probability of the first trial is success, second trial is success, and third trial is failure. So for this is probability of success, this is probability of failure. Success, how many success? This is one. So success 2, failure 1. So 4 10 square 2 and then 6 divided 10 square 1. So we have, this is the probability if the first trial success, second trial failure, and third trial success. So the probability we calculated by multiply. This is we can make a formula of the with replacement. We have a formula. This one we can have square upon the sum of success or failure, but in this case we just only have a multiplication. We multiply the first probability and the second probability and third probability. So the first one, maybe we want to know what is the probability. The first trial is failure, second trial is success, and the third trial is failure. So the first one failure. So we have the first one failure. We have
6 per 10.
6 and then 6 per 10 and then
Times
success we have
4 point
number success 4, number failure
6.
6. The first one is failure, the second one is success,
Success.
the third is failure. So we can calculate the first one. Success, berarti
4.
So 4
8.
hey, so
Oh. 9, yeah.
because we don't
Replace.
we can put why?
Why?
You understand what I mean? So just so this one. We have this one. So 6, 5, 4. So we have this probability if we have in the equation. The alpha is 1, 2, this is 6, 1, 2, 3, 4, 5, 6. So the probability of each of number is 1 per 6. So maybe if we have 2 dice, this is what this is a white dice and red die, white die. So this is probability 1 per 6. So this is in this one we calculate different. So what die the probability is 1 per 6. This is black die will be 1, 2, 3, 4, 5, 6. So the outcome is 6. This is the probability. If we want to know about the mean average, the average of the number that the occurrence that if we throw the dice and then we this show that maybe the white die is 1 and the black die is 1, so we have 1 plus 1 divided by 2 is 1. So this is the mean for the white die and the black die. So this is the intersection. So we have probability 1 intersection 1 is like this. This mean average of 1 and 2. So we have 1.5. So this is the mean. This is the intersection. This is the probability of the die. probability of the die have 1, 2, 3, 4, 5. This is the same. 1, 4, 6. And then this is the mean. 2, 1, and 2. This is 1. So this is only 1. If the white day is have outcome 1, and then this is 1, 1, 1. This is probability have 1, 2, 3, 4, 5, 6. Okay. And then if we calculate about the average of day 1 and day white day and red day, we have this mean. This is about the intersection. We have the same intersection for one intersection 1, one intersection 2, one intersection 3, and so on. So if we want to know about probability with means equal to 2, we have some alternative. 2, 1, and 3. So for the mean, the average of union of two dies, if we have mean 2, so we have probably 1 and 1 day 1, black day 3, and then white day 2, black day 2. So we have this average 2 plus 2 divided by 2, we have mean 2. 1 plus 3 divided by 2, this is mean 2. So if we want to know about probability, if the union of two dies, if we have one, this is actually mean 2, so this is the probability. Probability the white die 3 intersection with 1. So we can calculate about the probability. We have 2. This is 1 intersection 3, 2 intersection 2, 3 intersection 1. So we can calculate this. That is 3 per 36, and we have 1 per 12. Any question?
Mean 2 is the average, right?
The average, yes.
Is that like the question gonna be asked?
Yes. This is for this one. So from this probability, we can learn about this one. This is we call it about the probability distribution. In the maybe next weeks we will discuss about the distribution probability. So from this one we can calculate about mean 2. Mean 2 we have 3 per 36. So in this one, if we have mean 1, so this is for black die 1. Like white die 1. So the mean is 1. And then the second one, if we have black 1 and white 2, we have 1.5. So this is, we call it, we can make it some profile. This is a line distribution probability distribution. So this is dice probability. This is the fundamental we learn about distribution probability. So we calculate about the mean of the outcome. So 2, 1, 3, 3, 2. So mean is the average of the average. So in next meeting, this is the fundamental of the distribution probability, the probability distribution. So for the rest we have mean 1, 1.5, 2, and until 6. The probability is like alpha. For this is LBC. So we have 2, 1. Like 2 we have 1 per 12. So this is for 2 times, but if we have more than 2 times, we can calculate with this with square. And this is for the so if we only 1 times, we have probability. This is the probability. The outcome here 1. The outcome is 1, 2, 3, 4, 5, 6. So the probability is 1 per 6. 1 equal to 6. This one. For 1. And then for 2 times, this is only 1 time. This is 2 times. This is we have like alpha, like this. Okay. This is we call it probability distribution. This one because we have octane 1, 2, 3, 4, 5, 6. We call it discrete probability distribution. So they have one. This is we have integer number like this 1, 2, 3, 4, 5, 6. This is 2 times, and then this is 3 times, 5 times, and then 10 times. So if we have more and more times, the probability the shape maybe the same like this. We have a sample, but this is more rigid, more lebih dekat apa ya?
Compress.
Compress, and then if we more than that, more and more times, the probability is this one. More and more we have comprise, yes, and we can know about if it is one time and more times, the calculation become more complex, and we can approach it with the continuous distribution, a probability distribution. This is discrete distribution. This is before with except. This is before final. About continuous probability distribution. So this probability as a basic for linear across distribution. This is about the probability. So, you can the upper probability. So the total number of the card is 1/52, and then this one what is called one. Any guess?
Spade.
What?
Spade.
Spade,
And
yeah.
then
Clover.
No.
Clover.
okay, I do. This is called
Heart.
and then
Diamond.
Right. So this is for the diamond. This is something about 52. And then for two, we have only 4.
4.
So we can calculate all of this with different combination. So we can calculate about the number of sample space. This is number of sample space. This is die, and then plus, and then square plus FF. What is it? FF? Bias. So this game can be we can learn about the probability from probability proper, so we can calculate about the number about it, and we can calculate about the probability. Okay? And then now maybe equation.
The poker distribution, can it do that or no?
What?
For poker probabilities, but it's more complex than the dice one, right?
Yes.
It has more.
The probability of the poker more complex from the dice, yes. And then this is in this slide only about we calculate about the number of the flush, the number of straight that we can put. This is only the number of sample space, number of all of kind. This is the probability will occur this for kind of the way. Number of the way we can fall of kind is.
But is it possible for us to predict? Yeah.
Yes.
Oh, yeah. For example,
This one.
flash.
This one. This is the probability.
Oh, we can predict which when
When it's with the height, when we calculation with height, if we have good calculation in our brain, maybe we can calculate it.
Bisa dia.
This is the zero combination. Okay, what is different multiplication, combination, combination? Still remember? Okay. Permutation is the arrangement of all of the sub-elements of a set of distinct objects. So permutation estimates the number of placements with n member taken from n distinct objects considering the object. So permutation considered about this is the calculation of the permutation. F is the number of the N is number of different objects. number of if we have three number of different objects and we have three number of positions. So the permutation is 3, 3, 3. So 3 factorial divided by and 3 means minus 3 factorial. So we have 6. So if we have this one green and then yellow and red, this is green, red, yellow, this is a different. The order is important. This is for permutation. If we have 5 objects and then we have 3 positions, we have 16 ways. So this one. This is about the permutation. So when we have green, yellow, red, different positions. But combination is the arrangement of all or some like element of the set of distinct objects, where arrangements are distinguished only by difference in at least one object. So the difference in object, if the object is same, even though they have different order, is divided by this. So this is the object the same. So this is considered the same, not different. This is about the combination. About the formula, this one, N, C, F, N, F, A, C, N, F, or this one. N, F, and F, N factorial, F factorial, multiplied by N and F factorial. So this one, in permutation we have 6, but in combination we consider this as 1, only 1, because the object is the same. For the permutation we have now 6 ways, but in combination we consider it as 1. So the combination will be 1, 2, 3, 4, 5, 6, 7, 8, 9, only 10. Do you understand? This is what the next video. I promise